Welcome everyone, I'm Lizzie and I will be your host for today's sections on fundamentals of the frequency spectrum. So before we begin, please make sure that all of you have opened your camera and kindly note that this section will be recorded for future reference. So now let's start with a quick quiz to see what you have already known. So I have already shared the link in the chat box so you guys can access it to know your current understanding, and we will review the results shortly. Thank you. So here is your result. So it looks like we have a misunderstanding of the frequency spectrum so far. Maybe some of you already familiar with the frequency spectrum, but some maybe not. So it's okay. This session will help you to clarify this concept. And by the end, everyone should have a solid understanding of the frequency spectrum. So let's get started.
Let's start by understanding the purpose of frequency spectrum. It's the range of electromagnetic waves that powers nearly all forms of communication.
Is the voice okay? Is the voice okay?
Yes, I can hear.
Let's start by understanding the purpose of frequency spectrum. It's the range of electromagnetic waves that powers nearly all forms of communication, from radio and Wi-Fi to fiber optics. Radio waves are usually for broadcasting and cellular networks. Microwaves enables Wi-Fi and satellite communications. Infrared supports short-range devices like remotes. And finally, visible light forms the basis of fiber optics. The spectrum determines bandwidth and data rates. Higher frequencies enables faster speeds for technologies like 5G, whereas low frequencies are usually for long distance communications. Regulatory bodies manage the spectrum to ensure efficient and interference free usage for technologies like IoT and satellite systems. Why it matters? The frequency spectrum is critical for two main reasons. It enables global communication by connecting continents through satellite, submarine cables, and wireless networks. It supports education, emergency responses, and global broadcasting systems. Reason number two is that it drives digital transformation by powering innovations like 5G, IoT, and AI, while enabling technologies such as cloud computing, smart cities, and autonomous vehicles. In short, the frequency spectrum is the broad of global connectivity and driving force behind modern technology.
Hello everyone, today I'll be talking about the fundamentals of the frequency spectrum. The frequency spectrum is simply the range of frequency that can be found in a signal. It helps us understand how different frequencies contribute to that signal. So let's look at some key terms. The first one is bandwidth. The second one is frequency allocation, and the last one is signal modulation. Now, let's see some examples of how the frequency spectrum is used. So basically, it's used in radio for audio. It also can be used in television for video and audio. More, it can be used in mobile networks for calls and data. Finally, here are some frequency bands which are VLF, very low frequency, HF, high frequency, VHF, very high frequency, and UHF, ultra high frequency. Next, I'll be discussing frequency spectrum allocation. Frequency spectrum is managed by international and national rules. Government assign frequency bands to specific use to prevent interference. There are two key regulatory bodies involved: the ITU, or International Telecommunication Union, to set global standards. The second one is FCC, Federal Communications Commissions, to regulate spectrum use in the US. Furthermore, I will be discussing the application of the frequency spectrum in communication systems. The frequency spectrum plays a crucial role in various real-world applications, examples, mobile communication, satellite and GPS systems, and also radio and TV broadcasting. There are also some specific examples, which are public safety communications and IoT and smart devices.
Hello, my name is Aipan Haziq. I will continue with my slide, which is recent advancement in frequency spectrum technology. And what does it mean by recent advancement is the new technology that we get from frequency spectrum. And one of it is 5G spectrum development, which we have heard from and in our devices. Furthermore, there is also cognitive radio, which is a recent technology which will intelligently detect a tower that is not in use in order to make use of it fully from other types of channels, not just limited to phone channels, but also TV channels and so on. Furthermore, next I will discuss about the engineering impacts and societal benefits. And the engineering impact for the recent advancement is that spectrum efficiency, especially when we use 5G, it will become more stronger and faster. And we have enhanced communications and also scalable networks, since we can easily detect unused tower and use it fully. And global reach and also advanced sensing. Okay, now is the societal benefits. One of it is digital inclusion, which will expand our internet access, economic growth, since there is a lot of e-commerce nowadays, sustainability, because we reduce the environmental impact by using all the towers that are already present, public safety, smart cities, and also global collaboration, so that we have a more powerful connection throughout the world.
Now I will talk about misconception and challenges of frequency spectrum. The first misconception is radio waves continue on into space, which is not true. Actually, the further a radio wave travels, the weaker the signal becomes. The second one is having more Wi-Fi hotspots are better. Wi-Fi radio connects people to the hotspot, and when there are multiple connections to the same frequency band, the Wi-Fi signal will drown each other out. Now, the challenges of frequency spectrum, which there are two: spectrum scarcity and interference management. And next is case studies, learning from practical example. The first one is economy. A country can generate revenue by requiring the handheld device users to subscribe to the available wireless telecom service provider like Celcom, Digi, and others. And actually, a fun fact, wireless industry has stayed resilient while the world is facing an economy meltdown. The second one is natural disaster. Special forces are able to communicate with each other using a special line, and this has led a faster communication and a quicker response. Okay, to summarize this topic, the frequency spectrum has revolutionized communication, connecting people globally like never before. Its introduction has enabled organizations to enhance their services across various fields. This progress has contributed to stronger national defense, improved economies, and better social services, helping countries advance on multiple fronts. In short, the spectrum maps and transform the way we communicate and develop as a global community. The key takeaways from this topic is the spectrum can be understood as a channel used for a particular purposes, and international organizations are responsible to regulate the spectrum to avoid the interference with other signals.
So thank you for listening attentively. So now let's take a quiz again to see how much we've learned. So using the same link, you can try to answer it again. Thank you. So now let's review the results and see the improvement. So it's clear that any of you have grasped the key concept of the frequency spectrum. So this shows that you have absorbed the information well, and I'm confident that you now have a much stronger understanding of the frequency spectrum. So thank you for joining us today. I hope you found this section on the frequency spectrum both informative and engaging. So before we wrap up, please take a moment to fill our evaluation form. Now I share the link. Wait, So I have already shared the link. Please fill in and thank you for your participation.